Today, on How It's Made. Hockey gloves. Stick around and see how they take shape. Snack cakes. No half-baked ideas at this factory. Remoulded tires. Retired takes on a whole new meaning. And wastewater treatment, taking the ooh out of sewer water. Ice hockey can get pretty rough, so wearing the proper equipment is a must. Hockey gloves protect the forearm, wrist, and hand. A good glove has padding in all the right places, but is still lightweight and comfortable. It also has to be flexible, so the player can hold and maneuver the hockey stick well. The covering material of a hockey glove is called the outer shell. It can be made of genuine leather or synthetic leather. There's even a new synthetic material called carbon that's tear-proof, even if a sharp skate blade slashes it. What it's made of is a closely guarded trade secret. One hockey glove is made up of about 30 different parts depending on the model. Workers lay a die in the shape of each part on the outer shell material. A hydraulic press forces it down like a cookie cutter. Workers then cut foam pieces to line the glove. This low-density foam is stiff enough to provide protection, but flexible enough to enable the player to grip the stick properly. A seamstress now lock stitches the outer shell and foam lining parts together, assembling each section of the glove separately. After finishing the back of the hand, called the back roll, she pieces together the thumb. She sews 3 sides closed. One end stays open, so they'll be able to insert more protective foam afterward. These are the finger pieces. The seamstress uses a tacking machine to sew up the sides and tack the corners for added strength, again leaving one end, the top, open. Now they assemble the fingers to the base of the glove. They use what's called a cylinder arm machine. It has a narrow sewing surface that protrudes, making it easy to access the fingertips. Next come the parts that make up the palm and the gusset, the piece that goes between the fingers and the palm. Like before, workers cut the parts using a die. The palm and gusset can be made of high-end synthetic suede or leather, or even genuine leather. The advantage of real leather is that it can be treated with an antibacterial product that combats odor caused by the hand sweating inside the glove. Again, the seamstress uses the cylinder arm machine to sew the palm to the glove base, which already has the fingers attached. Next, the glove goes onto a machine that's custom-made for the hockey glove industry. Using air pressure to power a piston, it injects pieces of high-density foam padding into the open end of the fingers. High-density foam is rock hard, so it provides maximum protection. But high-density foam is too stiff to go into the thumb, which needs some flexibility. So instead, they make what's called an armored thumb plate, which is essentially a plastic thumb shield. A hot forge presses a flat sheet of hard plastic onto an aluminum mold in the shape of the plate. Then they wrap the plate in low-density foam and, with another machine custom-made for this purpose, inject it into the glove thumb. The lower part of the glove is now complete. A seamstress finishes off the edge with cotton tape. All that's left to do is assemble and attach the cuff. The standard cuff is about 6 centimeters wide. You can buy the gloves this company produces for retail stores or order customized gloves with your name embroidered on the cuffs. Professional hockey players have the factory build gloves to their own specifications, with extra protection in key areas or certain adjustments that they feel give them an advantage on the ice. The most important part of the glove is the palm. That's the area that endures the most wear and tear. The sturdier the palm material, the longer the glove will last. But at the same time, the palm padding can't be too thick. That would make the glove uncomfortable to wear and take away the player's feel for the hockey stick. When Marie Antoinette said, "Let them eat cake," she probably didn't mean those mini jelly logs. Still, in the realm of treats for the sweet tooth, snack cakes have been revolutionary. They're just the right size for a quick snack and individually wrapped to stay fresh. Veteran snackers will recognize this as a jelly log, a sponge cake rolled up with jam and a creamy filling. First, the factory bakes the sponge cake. It comes out of the oven in continuous strips. Those moving arms align the strips to receive the fillings. One machine then does it all. First, it deposits an even layer of cream filling, then blobs of strawberry jam. Now the rolling begins. One side of the cake strip runs against a metal guide. This lifts and folds over the edge. Then the cake strip runs against a second guide, which rolls it over some more. Now the machine cuts the continuous strip into separate cakes. Then an automated roller completes the logs. The jelly logs go into a conveyor belt that positions them closer together, aligning them for the next phases of production. They travel through a waterfall of strawberry-flavored syrup. This sticky coating acts as tasty glue to adhere the shredded coconut that showers them next. The conveyor belt shakes off the excess, which, like the excess strawberry syrup before, gets fed through the machine again. Now, if all this doesn't have your sweet tooth tingling yet, this next snack cake will. It's a chocolate cream cake covered in a chocolate coating. Production begins in the mixer, where they combine eggs, a vegetable oil mixture, flour, sugar, water, glucose, a liquid sweetener, and cocoa powder. The mixer blends the ingredients at high speed for 1 minute. Then it pumps the batter to a machine called the automated depositor, which squirts the batter into cake molds. The conveyor belt transports the mold pans to an oven where the batter bakes for 7 minutes. To achieve just the right texture, there's a very specific heating pattern. Once the pans exit the oven, a robot flips the cakes upside down onto a conveyor belt. It stacks the empty mold pans onto another conveyor that sends them back for more batter. Now the cakes flip right side up onto a wire conveyor belt. Air circulating between the wires cools the cakes. The next machine aligns the cakes in position for the next phases of production. First, thin blades saw the cakes in half. Then suction tubes remove the tops and place them next to the bottoms. Next, the machine drops a portion of cream filling on each bottom. The cream is about the consistency of margarine. As the feeder tube above each cake delivers it, a wire cutter slices off a piece about 6 millimeters thick. Then the suction tubes put the tops back on. Now the cakes pass through a shower of hot chocolate-flavored liquid. This coats the top and sides. At the same time, the cakes travel through a bath of the liquid. This coats the underside. Air jets blow off the excess. The cakes pass through a cooling tunnel. This hardens the chocolate-flavored coating. Then it's off to the packaging department. The cakes file into a sheet of polypropylene film. The machine seals, then cuts the film between each cake. This keeps each one fresh until snack time. If you need new tires for your car or truck and are looking to save money, you might consider buying retreaded or remolded tires. Retreads are worn-out tires onto which the factory glues new rubber treads. Remolds, on the other hand, are actually rebuilt. This company specializes in remolding commercial truck tires. The worn-out tire is called a casing. This is a cross-section. That steel reinforcement rod, called the bead, won't be replaced, but most of the rubber around it will be, along with most of the tread area. The steel belts underneath the treads, those dots, will remain. They begin the remolding process by thoroughly inspecting the casing to determine whether it's indeed salvageable. They consider its age, whether it's had repairs. They examine the steel components to make sure they haven't rusted. If the casing passes inspection, it moves on to the buffing machine. There, sharp blades spinning at high speed shear off most of the worn-out rubber tread. Buffing prepares the surface so that the new rubber will adhere well and stand up to road friction. Buffing takes about 6 minutes per tire. It leaves about 2.5 millimeters of tread on the casing. Now they use a tool called a skiver to shave off any imperfections. A rubber tire is like a car windshield. Even the smallest crack can spread outward, so it has to be stemmed. After excising problem spots, they smooth them with a grinding stone. Then they repeat the buffing, skiving, grinding procedure on the sides of the casing. But they use a less abrasive grinding stone because the sides don't need such aggressive treatment. Unlike the tread area, they won't be subjected to road abrasion. Now, using a drill, workers remove dirt and rust from each spot. Then, they work the area some more with a grinding wheel so that the rubber they'll use to patch it will adhere properly. Now they glue the patch from the inside with rubber cement, pressing out any air bubbles with a roller to ensure full contact. Workers can now start rebuilding the tire. They feed a rubber strip into a machine called an extruder. First, it heats up the strip, making it malleable. Then it wraps it onto the casing, building up anywhere from 2 to 4 layers, depending on how thick the customer wants the tire to be. That depends on several factors. For instance, how much traction the tire needs to have, and whether the truck will be doing mostly local or long-distance driving. Now they apply a wider rubber strip to the sides, building up 1 to 3 layers, the choice again depending on the customer's thickness needs. Using a perforating roller, they release the trapped air. This enables the layers to adhere well. Now they sprinkle the tire with rubber powder, residue from the buffing. This will prevent the tire from sticking to the mold. The mold consists of sections which allows it to open wide enough to receive the tire. The backward lettering inside will imprint the remolding company's brand name on the tire. The mold applies about 100 kilograms of pressure as well as heat, 160 degrees Celsius. This fuses the molecules in the old and the new rubber, a chemical reaction called polymerization. Once the mold closes to begin this process, a tube inflates with air and fills the void. This provides counter pressure so that the tire doesn't get crushed. Molding time is anywhere from an hour to an hour and a quarter per tire, depending on the thickness. After extracting the tire, workers remove the seams of excess rubber with a special comb. This remolded tire is now ready to hit the road at considerable cost savings. Depending on the size and type, a remold is 30 to 60% cheaper than a new tire.